స్టార్టెడ్ సార్ అది చెప్పండి, చెప్తే మేము చేసుకుంటాం.
నేను పైన ఉన్నాను సార్, ఇవాళ మొన్న చెప్పలేదు. పైన పెట్టాలి, కింద పెట్టాలి సార్. అక్కడ క్లాస్ పెట్టినప్పుడు రావాలి సార్.
చెప్పేస్తే morning children. I will continue the ethers topic. So yesterday we have seen one important methods of preparations, right? Next we see one more important method, that is Williamson's synthesis. Williamson's synthesis. So this is most important method of preparation of ethers. In the Williamson synthesis, alkyl halides are treated with alkoxides. Alkyl halides treated with alkoxides. Alkyl halides treated with alkoxides to get ethers. Right children? For example, I take RONA. This is sodium alkoxide. Sodium alkoxide treated with alkyl halide RX. Then we will get ROR plus NaX. This is ether. What we get the product. So alkoxides treated with alkyl halides. You know how to get alkoxides. When alcohols reacted with metals like sodium, we will get sodium alkoxide. If we take common example, CH3ONA plus CH3I. I take this. Then we will get CH3OCH3 plus Na. This is dimethyl ether. Dimethyl ether. Suppose if I take CH3, CH2, ONA plus CH3, CH2, Br. Then I get CH3, CH2, O, CH2, CH3. This is dimethyl ether. Because sodium ethoxide treated with ethyl bromide. So this Na and Br will get here, NaBr. This is no need to write. Suppose if I take CH3 O Na plus C2H5I ethyl. Then again we will get here CH3O C2H5 plus Na. This is ethyl methyl ether. These two are symmetrical ethers. This is unsymmetrical ether. Dimethyl ether or methoxymethane, diethyl ether or ethoxyethane, and this is ethyl methyl ether, that is methoxyethane. Methoxyethane. Right, children? Here the reaction proceeds in SN2 way. That means here formation Williamson synthesis follows SN2 mechanism. Whenever SN2 mechanism is followed, primary alkyl halides are favored. It's very important here, right? So therefore halides should be primary. If primary halides are favored, because this is SN2 mechanism, whenever you take primary halide, the substitution reaction takes place. Right, children? Suppose when you are taking secondary and tertiary, definitely when you take secondary, there is a combination between substitution and elimination. So that depends on the conditions. If you take tertiary, definitely it goes elimination. It goes elimination. We won't get to substitution product. This is very important information. That means halide should be primary. If it is primary, SN2 mechanism, it follows. If halide is tertiary, it follows elimination. Elimination reaction. If halide is secondary, competition between elimination and substitution. Elimination and substitution. So this is a very important information about this reaction. Right, children? Williamson synthesis follows SN2 mechanism. You know that for SN2 mechanism, substitution nucleophilic bimolecular, primary alkyl halides are more reactive. So therefore primary alkyl should be there. In case of secondary, both are positive. That is combination between secondary, combination between elimination and substitutions. In case of tertiary, only elimination takes place. There is no substitution. So if I want tertiary ethers, then how to get the ether? Tertiary ethers. Because when I take tertiary alkyl halide, it proceeds through elimination mechanism. So you know that whenever elimination takes place, you will get alkenes. You won't get to ethers. Then how to get to ethers with tertiary group? For that, yes, there is one chance. What is that? Alkyl halide should not be tertiary, but alkoxide you can take tertiary. Alkoxide can be taken as tertiary. This is important reaction, right? So one more example for tertiary ethers. For tertiary ethers, you need to take alkoxide, CH3, C, CH3, CH3, O, Na. This is sodium tertiary butoxide plus methyl halide. CH3, C, CH3, CH3, O, CH3 plus Na. So I got tertiary butyl methyl ether. Right? That means when I want tertiary ethers, you can take alkoxide tertiary, but you cannot take methyl alkyl iodide tertiary. For example, if I take reverse CH3, C, CH3, CH3, I plus CH3, O, Na, or you can take Cl, any halide, whether Cl or iodine or bromide. So in this case, what we have? So you are supposed to put NaCl and tertiary ethers, but in this case it is not possible. Then what is possible? The possibility is alkene. So we get CH3, C, double bond, CH2, CH3, 1, 2, 3. Right? 4. 1, 2, 3, 4. And then this is NaCl. NaCl. That means what we have done? This is plus CH3 OH, CH3 OH, right? Then this one 1, 2, 3, 4, 1, 2, 3, 4. Then so these are the products here. That means when you take here, this is preparation of either, you will keep it. So I am taking reverse. This is important for the objective examinations. If I take reverse, what will happen? Whenever we take tertiary halides, elimination takes place. Why this happens? You know that this is methoxide, sodium methoxide minus plus. This methoxide ion says 3 O minus. Methoxide ion is a nucleophile as well as it acts as base also. So methoxide ion is a nucleophile as well as base. So since it acts as base in this, it won't act as nucleophile. Why? What is the reason here? Right? Base means what is base here? Base can abstract the proton. Which proton? Acidic proton. Acidic proton. You know that these protons are alpha. These are the alpha hydrogens. Right? Alpha hydrogens are acidic. We know that. So therefore, all these groups are similar. So methoxide ion pulls this one. Hydrogen. One hydrogen. So that methoxide plus hydrogen gives methyl alcohol, and when hydrogen is pulled from this, we get alkene. That is CH3, C, double bond CH2, CH3. CH3, C, double bond CH2, CH3. Alkene. Why not it acts as nucleophile? So same methoxide ion acts as nucleophile. You know that the nucleophile can attack electrophilic carbon. Nucleophile can attack electrophilic carbon, that is positively charged carbon. What is the positively charged carbon in this case? When this is cleaved, this is the positively charged carbon, C plus and Cl minus. This is the leading group. Chloride is the leading group. This mechanism you have studied in the first year. Whenever this hydrogen is removed with base, the electrons are shifted to this bond, and then this can leave as Cl minus. Cl minus and Na plus will get NaCl. So here in this case, what you get is C plus. carbocationic. The approaching of methoxide ion to this electrophilic carbon is difficult because of steric factors. Because this electrophilic carbon is surrounded by 3 methyl groups. So because of 3 methyl groups, there is lot of steric effect in this case. Because of steric factor, this nucleophile, that is methoxide ion, cannot approach this electrophilic carbon. So therefore we won't get ether. We won't get ether. But whereas in this case, what is there? This is tertiary butoxide ion and this is methyl group. So what will happen? Tertiary butoxide, this is a nucleophile, can attack this methyl, that is electrophilic. It is very easy in this case. Very easy in this case, the approach, because the groups are hydrogen atoms. So therefore there is no steric factors. There is no steric factor. So this is a very important difference and explanation regarding these two children. So very important reactions. So whenever you are going to get tertiary ethers, you must take tertiary alkoxide and primary alkyl halide so that you can get the ether. When you take reverse, tertiary alkyl halide and primary alkoxide, you will get alkene, because in this case elimination takes place. Why? Because tertiary carbocation is more stable, so therefore elimination. Steric factors are there. Because of steric factor, the nucleophile cannot approach electrophilic carbon. The groups can obstruct the approaching nature of this. So therefore, it can approach acidic hydrogen and remove the hydrogen as methyl alcohol. You will get alkene. Alright, children? This is a very important reaction here. You need to remember. Right? Williamson's synthesis. Next, one more example, similar example. Suppose I take, I want either with phenyl group, then what will happen? Same thing, suppose if I want this phenyl ether, I need to take phenoxide ion plus CH3I gives rise to OCH3 plus NaI. Right? We will get anisole. Methyl phenyl ether anisole. Right, children? For example, if I take reverse, this is alkyl halide, this is alkoxide, CH3O Na minus plus. So this reaction we cannot get. Right? Why? Because here the alkyl halide, the chlorine, halogen atom, any halogen atom, the lone pair is in conjugation with benzene ring. So therefore here CCl band gets double bond character. CCl bond gets a double bond character. So this cleavage of this one is difficult. So therefore whenever you take, this is chlorobenzene or bromobenzene, anything, right? With alkoxide, you won't get ethers. So whenever you want to get phenyl alkyl ethers, so phenoxide ion should be advisable. Phenoxide ion, you need to take phenoxide. So this can be changed. So methyl iodide, you will get anisole. If I take ethyl iodide, you will get phenol. There is no problem. So whatever you are taking, that remember that that's phenyl group with alkoxides. Metal alkoxide. Sorry. This is phenoxide ion. Phenoxide and alkyl iodide. If we take, this is halobenzene and alkoxide, this is not possible because of this double bond nature. This bond cannot be cleaved easily. Right. This is also same. To get tertiary ether, alkoxide should be tertiary. To get phenyl alkyl ether, phenoxide should be taken. Phenoxide should be taken. That means if I take then you can take there is no problem. No need to take one more example. In place of this one, if you take ethyl group, you will get phenol. That is already we have seen. Plus C2H5, C2H5I. Then you will get phenol. C2H5 plus NaI. This is phenol. These two reactions are normally asked in the preparation properties and preparations also. Alkyl halide properties, and then preparation of ethers. So reverse. So you take again similar reaction is not possible. That is iodine is here, alkoxide here. It is not possible. So these are the very important concepts of Williamson's synthesis. Now let us go for properties. Physical properties. If you take physical state, these are the volatile liquids or gases. They exist as liquid state or gaseous gas, but are volatile. These are volatile. That means they are having very low boiling point. So therefore, whenever you are handling the ethers, you should be very careful because ether vapors can catch the fire very easily. So whenever you are using the ether bottles in the laboratory, you should not keep the bottle open near the Bunsen burners. If it takes place, definitely you can face these fire accidents. Immediately the vapors can catch the fire. That is one. Then solubility. When you take this one ether, since oxygen is carrying lone pairs, able to form hydrogen. So able to form hydrogen bonds. So definitely they are soluble in water. Soluble in water and in organic solvents also. Organic solvents. So this is one more point. This solubility is not like alcohols. Alcohols are more soluble, but these are slightly soluble. Then boiling point. When compared to boiling points, having less boiling points than alcohols. When you compare to alcohols, these are having low boiling points. Low boiling point. When compared to alkanes with comparable mass, they are having almost same boiling points. That is next structure. When you take the structure of water, you know that this is water with two lone pairs, 105 degrees. Similar structure is observed in ethers, CH3. This is 112 degrees. That means because of repulsion between two methyl groups, bond angle is slightly increased. Slightly increased. If I take bulky group CH3 thrice C. This is CH3 thrice C. This should be 130. That means what happened? The alkyl group size increases, bond angle increases because of repulsive forces. Because of repulsive forces. So here see this is tertiary butyl. Two tertiary butyl groups are attached. So tertiary butyl groups are having lot of what is that? Spatial repulsions. So methyl groups are oriented around the carbon atom. So therefore, because of spatial arrangement, the steric factors influence a lot. So because of steric factors, same. Next one more, auto oxidation. Ethers are exposed to air. It forms explosive compounds. For example, CH3, CH2, O, CH2, CH3. This is exposed to air. Air means O2. Then we get CH3, CH2, O, CH, O, H, CH. This is hydroperoxide. Hydroperoxide. Again, we get CH3, CH2, O, CH2, CH3. This is peroxide. That means when ethers are exposed to air, it forms two types of compounds, hydroperoxides and peroxides. Peroxides can decompose with releasing of a lot of energy. That's why they possess explosive nature. Explosive nature. This is auto oxidation. Right, children? So these are the physical properties of this one. Next, chemical properties. Chemical properties. The first one is reaction with HA. Reaction with HA. HA is the strong acid, right? When you take these reactions, so I take C2H5 O C2H5. When it is treated with HI, then what will happen? C2H5 OH plus C2H5 I. Ethyl alcohol and ethyl iodide. Again this ethyl alcohol C2H5OH reacts with HI, so that you will get to C2H5I plus H2O. Now when you observe these two reactions, whenever ether reacts with one molecule of HI, one molecule of HI, this is one molecule, then you will get one molecule of alcohol, one molecule of alkyl iodide. Alkyl iodide. If I take two molecules, that means one molecule here, one molecule here, one more molecule. Then we will get two molecules of alkyl iodide. So alcohol is intermediate. Alcohol, right? Yes. So ethyl iodide, ethyl iodide. So that means what is here? When I take diethyl ether C2H5O C2H5 plus 2HI, the product is two molecules of C2H5I plus H2O. This is the one. This is two molecules. That means this is one molecule, this is two molecules. Or sometimes the same question is given that excess of HI. Excess of HI means you need to consider two molecules. And same question is given that concentrated HI. You need to consider two molecules. Same question is asked that hot HI, hot condition. That is also excess reactions. So simply they change the wording. You remember that children? If one molecule of HI is treated with ether, you will get one molecule of alcohol, one molecule of alkyl iodide. If two molecules of HI is treated, we don't have alcohol because the alcohol molecule which is formed during the reaction can be converted into one more alkyl halide molecule. So final products are two molecules of alkyl halide plus water. This is very important reaction. Okay. If I take unsymmetrical ether, that is CH3O C2H5 plus HI. Now you see this. If it is symmetrical ether, there is no problem here. Oxygen is with this group or with this group. There is no difference in this because both are having same alkyl group. Alkyl halide or the alcohol. If I take unsymmetrical ether, then to which group iodine should be added, which group H should be added. This is very important. So in this case, you have to write the product CH3I plus C2H5OH. That is, what is the conclusion here? In case of unsymmetrical ethers, halide ion is with less substituted alkyl group. Right. This is the important point you need to remember about this. This is CH3. This all are methyl hydrogens. If it is ethyl group, one hydrogen is replaced, substituted by methyl group. So you know that ethyl means HCH. So substituted more group. If it is methyl, H. So which is more substituted? This one. Which is less substituted? This one. So therefore the halide ions or halogen atom is with less substituted, right? Less substituted alkyl group. That's why we have got CH3I. CH3I. If I take one molecule, one more example, say 3CH2, CH2O, CH3, CH. So which one is less substituted? This one, because this carbon 2 hydrogen 1 ethyl group. This carbon 2 methyls and hydrogens. So this is more substituted. So in this case, if we take HI, then what will be the product? CH3, CH2, CH2, I plus this one CH3, CH, CH3, OH. Iodine is with less substituted group, this group, and hydrogen is this group. This is isopropyl alcohol. Isopropyl alcohol. This is one more example. If you take one more example, suppose CH3, C, CH3, CH3, O, CH3 plus HI. So in this case, suppose in this case when you take this one, right, this is less substituted, we are supposed to get CH3I plus tertiary butyl alcohol, but in this case, what will happen, the product is CH3, C, CH3, CH3I plus CH3OH, CH3OH. So why this happens here? Because in this case, the reaction proceeds in the SN1 mechanism. It follows SN1 mechanism, and here the alkyl carbocation formed is tertiary butyl carbocation. Tertiary butyl carbocation is more stable. That is CH3, C plus. Tertiary butyl carbocation. Tertiary butyl carbocation is more stable carbocation. So therefore, in this case positive. Therefore, iodine will approach this one. This is the important point here, right, children? So these variations you must remember. You should not simply go blindly in chemistry. It won't work out. These variations, exceptions are very, very important while learning the concepts. Now you can see this. This is unsymmetrical either. There is no problem. If one molecule reacts, one molecule alcohol, one molecule alkyl halide. If two molecules react, only alkyl halides are formed. Why? Because the molecule which is formed in this alcohol is again converted to alkyl iodide. This is the reaction. If you take unsymmetrical ethers, the halogen atom is with less substituted alkyl groups. Two examples I have given. In case of tertiary compounds, in this tertiary compounds, tertiary ethers, tertiary butyl carbocation is more stable. Because of that, the halogen atom is with tertiary butyl. So you get tertiary butyl iodide, and you will get methyl alcohol. Methyl alcohol. Right, children? This is very important. Second one, hydrolysis. So ethers, CH3, CH2, OCH2, CH3, dilute H2SO4. When these are hydrolyzed, we will get 2 CH2, CH3, CH2OH. We will get ethyl alcohol, two molecules of ethyl alcohol, 2 CH3, CH2OH. This bond is cleaved, hydrolyzed, HeOH, adding water. Next, with PCl5. When you take with PCl5, that is CH3, CH2O, CH2, CH3 plus PCl5, phosphorus pentachloride. Then you will get 2 molecules of CH3, CH2, Cl plus POCl. That means 2 molecules of alkyl halide is formed. ethyl chloride. 2 molecules of ethyl chloride plus POCl. Next one with acyl chloride, CH3COCl. Then what will happen? You take CH3 diethyl ether only. I am taking very common ether, CH2O, CH2, CH3 plus acyl chloride, CH3COCl. Right children? The bond is cleaved in such a way that what is the product here? CH3, CH2, O, CO, CH3 plus CH3, CH2, Cl. Ester, you will get ester. What is this ester? Ethyl acetate. This is ethyl and this is acetate. Ethyl acetate. If I take acidic anhydride, that is CH3, CH2O, CH3, CH2, CH3 plus acidic anhydride CH3, CO, O, CO, CH3. Acetylation can be done in 2 cases, that is as with acidic anhydride and acyl chloride. Same thing. So when you cleave this bond, you will get ester. Other part also ester. So you will get 2 molecules of ester only. That is 2 CH3, CH2, O, CO, CH3. 2 molecules of ester. Right children? Hydrolysis, first one with alkyl halides. Hydrolysis with PCl5 with acyl chloride, acidic anhydride. This is the second reaction. This is 1, this is 2. And then with halogens. Next one with chlorine. When you take chlorine, with chlorine there are 2 possibilities. In presence of sunlight, in the absence of sunlight. 2 cases. That means in the dark conditions and in presence of sunlight. 2 cases we are going to get 2 products. Suppose first one CH3, CH2, O, CH2, CH3. This is treated with chlorine in dark. So in dark conditions, when chlorine is treated with this, the alpha hydrogens are replaced by chlorine. What are alpha hydrogen? This is alpha hydrogen, this is alpha hydrogen. So what will be the product here? CH2, CHCl, O, CHCl, CH3. Of course, this reaction is carried out in 2 steps. First step, alpha chloro diethyl ether. Second one, alpha dash dichloro diethyl ether. Alpha dash dichloro diethyl ether. Right? First step 1 chlorine, second step 2 chlorines are reacted because these 2 are similar, identical groups. In presence of dark light, so this is CH3, CH2O, CH2, CH3 plus Cl2. In presence of light, that is Hnu, all the hydrogens are replaced. That is C, Cl, Cl, C, Cl, Cl, O, C, Cl, Cl, C, Cl, Cl, Cl. That means what happened here? Whenever the chlorine is treated with ether, in presence of sunlight, all the hydrogens are substituted. So alpha hydrogens in dark condition we will get alpha substituted. That is monochloro dichloro. Two products we can get. Monochloro dichloro. If it is in presence of light, all hydrogens are replaced by this chlorine atom, so that we can get this chloro substituted ether. So these are the one category of examples. Tomorrow will be set electrophilic substitution reactions. Tomorrow we are going to complete this chapter, electrophilic substitution reactions. Thank you, Chetan.
Okay, children. Good morning, everyone. So yesterday evening I sent the remaining numericals in dual nature in WhatsApp. So time being, I will start today a new lesson: moving charges and magnetism. The weightage of this chapter is nearly 9 marks. Biggest chapter and very important also. Moving charges and magnetism. Moving charges and magnetism. So lesson name is moving charges and magnetism. Okay, so first of all you should know what is a magnetic field. Magnetic field, I think by this time, means by today, all of you know about the magnets. Okay, so in childhood also you are playing with magnets and magnetic materials. See, so if you take this as a bar magnet, north pole and it is a south pole. It is a bar magnet. Okay, children. Now, if you place this bar magnet with this bar magnet, it influences certain region. It influences certain region. Means, if you place any another bar magnet, here, okay. So if you place here north and here south, what happens? This north pole will repel this north. Okay, children. And if you place here south pole, it means one more magnet like this. If this is south pole and this is north pole, so this north pole may attract this south. So your attraction is there, here repulsion is there. Okay, children. So now, if you take a magnetic needle, which is very important, magnetic needle. So magnetic needle is a small magnet which contains the north pole and south pole. Which contains the north pole and south pole. Generally we will draw like this. That's all. This arrowhead indicates the north. The tail indicates south. Okay, children? The tail indicates south. This is north. This is the south. If you place any magnet near to the magnetic needle, this magnetic needle will deflect. It will deflect. Means this may turn like this if you place. Okay, children. So why this magnetic needle is deflecting? Because near to this there is a magnet. Means this magnet can influence certain space around it. That is called magnetic field, like electric field. Okay, the space or region around a magnet within which its influence is felt is called magnetic field. Okay, children. So if you place any magnetic material, so the space around this magnetic material, maybe this is north, maybe this is south. The space around a magnet in which its influence is felt is called magnetic field. We know that already, similar to electric field. Okay, so before 1820, so we are going to flashback. Before 1820, what the world know is the magnetic field can be produced only by the magnets. Only by the magnets. And a magnetic needle can influence if there is magnetic field. These two remember. By before 1820, what our scientists knew or we knew means a magnetic needle can be deflected with the magnetic field only. Then what is the source of magnetic field? Magnets only. Okay. So before 1820, magnets can alone produce magnetic field. The only source of magnetic field is bar magnets or magnets, right? But in the year 1820, in 1820, Hans Christian Oysters, he was the scientist, so he is a lecturer and scientist. Okay, just listen, children. Before 1820, our scientists thought that electricity and magnetism are entirely separate topics. Before 1820, our scientists thought that electricity and magnetism were separate. Means they are not depend on each other. But in the year 1820, a lecturer come scientist named Oysters. Remember as Oysters. Okay. So while he was giving one demonstration, students all are sat in their places, and on the stage, lecturer come scientist Oysters, while he was giving one demonstration. Okay. So what he observed, when he allowed sufficient current in a conductor. He took one wire. There was an experimental bench. Okay, there was a battery and a conducting wire. Okay, he sent current through the wire. The moment he sent current through the wire, he observed deflection in the magnetic needle on the bench. Okay, so nearby this set current wire, there is a magnetic needle. Magnetic needle, he observed deflection. So he thought that magnetic needles will deflect in the magnetic field only. But there were no magnets that time on the bench. He called students and he ordered close all the doors and windows, because he thought the air from outside may disturb the needle. Okay, so all windows and doors closed. Magnets also kept away from his arrangement. Again he sent current. Again he started experiment. Okay, so again when current flows, again the magnetic needle deflects. Again he confused. So now no air inside the room, no needles present on the table, no magnets are not there. But again, why this magnetic needle deflected? Why it disturbed? Okay, again he sent current, again deflected. When he sent current in the opposite direction, the deflection also opposite. When he increased the current, deflection increased. When he decreased the current, deflection decreased. So finally he concluded that there may be a relation between this experiment and the deflection in the magnetic needle. And one thing I think we know, a magnetic needle will deflect in the presence of magnetic field only. Means there may be a magnetic field. But how? Magnets were not there. Then he concluded that when current passes through a conductor, it produces what? Magnetic field around it. If any magnetic needle is near to the conductor, what happens? It influenced by the magnetic field, it will turn, it will deflect. So the conclusion is moving charges produces magnetic field. Means there is a relation between electricity and magnetism. Understand? So there is a question in first PUC physical world. Name the scientist who unified electricity and magnetism. The answer, one of the scientists is who? Oysters. Children, so this is Oysters' conclusion. Whenever current passes through a conductor, it produces magnetic field around it. Means a current carrying conductor produces magnetic field. Okay, so conclusion. So now our concept is Oysters experiment. Oysters experiment. Okay, children. So after experiment, what he concluded? A current carrying conductor. A current carrying conductor produces magnetic field. Magnetic field around it. Okay, children, means a moving charge can produce magnetic field. See, a moving charge can produce magnetic field. Reverse also possible. Magnetic field can affect moving charge again. So that is also we have in the syllabus. See, just listen. Moving charge can produce magnetic field, and in turn magnetic field can influence moving charges also. Understand, children? So now, what are the sources of electric field? Not only magnets, moving charges also source of electric field. I think you know everyone, electric cranes. You know electric cranes to lift heavy objects. How they will work? It contains a large iron rod. Okay, so you also can do in your home, if possible do today only. Take one iron rod, just take one iron rod, take one copper wire. Okay, so wound copper wire on that, you will get two ends. The two ends is connected to battery opposite terminals. After a small time, the iron rod becomes a magnet. So that is called electromagnet. Once you switch off, magnetic field also becomes zero. So now their magnet is produced. Magnetic field is produced because of current. That's why current produces magnetic field. Current means what? Flow of charges, moving charges. So moving charges produces magnetic field. Electrons also produces what? Moving electrons produces what? Magnetic field. So understand, children? So what is Oysters' conclusion? A current carrying conductor produces magnetic field around it, or a moving charge can produce a magnetic field. Then how he did the experiment is, just see here. So this is his experimental arrangement. Okay, so this is the battery. And this is like key. This is a key. Okay, children. So this is a positive terminal, and this is a negative terminal, right, children? Okay. So this is like a key. Okay. So now you know current flows from positive terminal to negative terminal. This is the current direction. This is the current direction. Okay, children. So when current passes through this conductor, okay, the magnetic needle, just take this as a magnetic needle, small needle. So the shaded is north. The shaded part is north, and this is south. Okay. So the moment when current passes, the magnetic field means the magnetic needle is deflected like this. Essentially, see, if you place like this only, this is Y, na? This is Y. If you place here needle, so what happened to the children? Just it deflected. It deflected. Understand? So, for example, see here. We know this is east, this is west, this is south, this is north. Understand? So when current passes from south to north, when current passes from south pole to north pole, the magnetic needle deflected towards the west side, like this one. When current passes from south pole to north pole, the magnetic needle deflected towards the west. Here west is this is east, this is west, so it is deflected west side. Understand? See, when current flows from south pole to north pole, the deflection is over west side. This is snow rule. Snow, S-N-O-W. Understand? See, if this is the needle, when current flows from south to north, the deflected is towards the west side. Similarly, if current direction changes, if this is the current direction, when current direction changes, then the magnetic needle deflected towards the east side. Now see, actually we cannot draw diagrams in 3 dimensions because board is a 2 dimension, right? Now see, if this is the magnetic needle, when current is passed from south to north, like this, here to there, now it deflected towards west side. If current passes from north to south, the deflection is towards the east side. Yes or no? Yes. Or here also you can take. This is if it is north, if it is south, east, west. If current passes from south to north, the deflection is towards the west side. Otherwise, east side. But whatever may be, the conclusion is, whenever current passes through a conductor, what happens? It produces magnetic field. So this is Oysters' conclusion or Oysters' experiment. Okay, children? Then this is magnetic field. So it have direction also. Magnetic field have a direction. Okay. See, if you take this as magnet, this chalk piece is taken as a magnet. Yes or no, children? So whenever current passes through like this, okay, current passes like this, then if you place a magnetic needle, then it deflects how you know, like this, because west is that side, it deflects towards the west side. If you change the direction of current, then the deflection is towards the east side. Whatever may be, okay, direction of current, there is a magnetic field. And he did one more experiment also. Okay, what is that? He took a straight conductor, straight wire, and he allowed current. Okay, and he took small iron pieces. He dropped on the wire. How the pieces aligned, all the pieces aligned in the form of a circle. Why? So the magnetic field is along circles. Okay. So if you have this arrangement in your home also, we can do this a simple experiment. Okay. For this you want one wire, one straight wire, one battery, and small iron pieces. If you pour on it, immediately it aligned in the direction of what, children? Just circles. Okay, I think you understand now. So before 1820, our scientists thought that there is no relation between electricity and magnetism, but they are interrelated. We can produce electricity from magnetism. We can produce magnetism from electricity also by using this famous Oysters experiment. And this, remember, snow rule. Snow. If current is from south to north, the deflection is towards the west side. Reverse. If current is from north to south, the deflection is towards the east side. Okay, children? So now this is the conclusion. A current carrying conductor produces magnetic field around it. Then, if you take magnetic needle, how they aligned, I told already. How? See, if this is board, if this is board, if this is current direction, then the magnetic needle is moving towards like this. Means what? Into the board. It is going into the board, and if you opposite it turns out of the board. See here, children. See here into the, here out of the, means just imagine one round, children. Imagine one round. That is what, children? A circle. So the magnetic field due to straight line is concentric circles. Concentric circles. Now just I will draw one more diagram here. See here, children. When current flowing into the board, into the board means like this. Okay, children? Into the board. How the means like this, children? Into the board. You have to use the symbol cross. Cross symbol. Okay, children? See. This is this thumb into the. This is out of the. Understand, children? Now see here. This, remember, when current passes from south to north, the deflection of the needle is towards the west side, like this. Otherwise, east side. Okay. Now see here. Now I will take current into the. This is the symbol. Cross. Current is flowing into the board, means like this. Okay, children? Now, how the magnetic needles aligned? See, the magnetic needles aligned as a concentric circles. So, like this, children. This is a magnetic needle. They are aligning like this. Okay, children? So they are coming like this, children. Aligning like this. Magnetic needle. This is north pole, children. Like this, okay? Okay, children? Like this. So you can draw like this totally also. Okay, children. Right? This we have to understand. Here, right? So this is what see this my right hand, this thumb. Okay, so if thumb indicates Thumb indicates what, children? Current into the, now this is the, like this, the magnetic needle will deflect. If you take the current flowing out of the board, means what? Current is like this, for example, then the deflection is in the opposite direction. So here what we have to understand the conclusion means, whenever if you take a straight wire, if this is a straight wire, see children, see, if this is a straight wire, if current is flowing in this direction, then the deflection is towards like this, and like this. So you can imagine what, children? A circle. The magnetic field is in the form of concentric circles. Very important, children. So write down here. So if current flows through a straight conducting wire or straight conductor, then the magnetic field is in the form of concentric circles with conductor as center. See, if this is current carrying conductor, then the magnetic field around it is what? Circle. Understand, children? And the magnetic field at any point is, which is very important, the magnetic field at any point is perpendicular to the current carrying conductor. All these are observations by Oysters experiment. Okay, children? So now just listen the conclusions of Oysters experiment. When current passes through a conductor, it produces magnetic field. If current direction changes, magnetic deflection also changes. Okay, children? And the magnetic field around the conductor is in the form of concentric circles, and the magnetic field direction is perpendicular to the current carrying conductor. You know, children, if this is that, if you place here a magnetic needle, the magnetic needle deflects like this. Okay, means perpendicular. See, my hand and the wire exactly perpendicular. Yes, sir. At this point also like this, it is my hand and this wire are perpendicular. So if you do experiment also, you will get the same conclusion. The magnetic field at any point due to that wire is perpendicular to the current carrying wire. Okay, just you have to imagine, children. See, the deflection may be like this, or the deflection may be like this, into the, out of the, but it forms what? A circle. At every point there is a magnetic field now. So what is this is, if current flows through a straight conductor, then magnetic field is in the form of concentric circles with conductor as center. Okay. So today evening I will send notes also, children, for these two classes. So snow rule also remember, south to north deflection is over west. Now, how to know the direction of these currents? There are some rules, children. Direction. I think you know, you learned in lower classes. Direction of magnetic field. You know, children, direction is vector quantity. You know E bar electric field intensity, like that magnetic field intensity, vector quantity B bar. E electric field intensity, B bar magnetic field intensity symbol. Right? So first of all, Ampere's swimming rule is there. You know, swimming rule. Ampere's swimming rule, which is very important, right? For this, imagine a person is swimming in the direction of current. A person is swimming in the direction of current. Okay, children? A person is swimming in the direction of current. So this is the direction of current. Okay, facing a magnetic needle. Facing a magnetic needle. I will place here magnetic needle. So this is the north pole, this is the south pole. Okay, children. So imagine a person swimming in the direction of the current. Then the north pole of the magnetic needle deflects towards his left hand side. Deflect towards his left hand side. This is left hand side. Yes or no? See, if it is come like this means it is coming right hand side. But how it is going? It is deflected towards what? Left hand side, which is very important, children. Again listen. And all are same. See here. If this is south pole, if this is north pole. Here the magnetic needle deflect like this. West side. Okay. Same here. So again listen. Ampere's swimming rule. Okay. A person is swimming such that he is swimming in the direction of current, facing a magnetic needle. Facing a magnetic needle. Okay. The magnetic needle contains two poles, north pole and south pole. So if he is swimming in the direction of current, then the north pole deflects towards his left hand side. Towards his left hand side. See, south to north. If he is moving from south to north, see here. This is south pole. This is the north pole. Okay. So then this is what? East. This is what? West. If he is moving, current is from south to north, then deflection is towards what? West. Snow rule again. Understand? So this is very important. Just to remember the direction only. Imagine a person is swimming in the direction of current, facing a magnetic needle. Okay. Then the north pole deflect towards his left hand side. If he swims in the opposite direction, then the north pole deflects towards his right hand side. If you have any confusion in this rule, we have one more rule which is very easy. Okay, and we are using that rule only mostly. Just listen this. This is what Ampere's swimming rule. How? Imagine a person is swimming in the direction of current, facing a magnetic needle. Then the north pole of the magnetic needle deflects towards his left hand side. This is one rule. Okay, but we are not using this rule. We are using one powerful rule which is very important. If you understand this, you can answer so many questions also. So the second rule is rule. Now imagine, I'll take like this. See, imagine I'll take this as a conductor. Imagine a conductor, a current carrying conductor, okay, in your right hand. Okay, children, such that the thumb indicates the direction of current. Then the curl is there, the folded fingers, 4 fingers are there. The curl of the 4 fingers indicates the direction of magnetic field. Okay, children, if current is upward direction, the magnetic field is into the board. Just see my 4 fingers, thumb. If current is in the upward direction, then the 4 fingers, this is circle. Yes, the magnetic field is into the board. Yes, sir. If current is in the downward direction, how my 4 fingers are out of the board. See, if current is downwards, field out. If current is upward, field is into the board. Okay, so now see here. So in right hand, okay na? In right hand, thumb indicates what, children? Direction of current. Okay, now the curl, curl means what, children? Folding, encircle. This is encircling. Curl is folded. Curl of 4 fingers indicates magnetic field direction, children. Magnetic field direction. Okay, so now I will give some examples. Just concentrate carefully here. See here. See, this is current carrying conductor. How? Like this only. We know already the magnetic field around a straight conductor is circular, concentric circles. Yes or no? Concentric circles. So I will draw a circle. Now at this point, what is the direction of magnetic field? We know the direction is given by the tangent at any point, right? Now just look at me. See here. See, like this. See my finger. How? See here. My finger is in the direction of current. Then how my 4 fingers are? See, it is into the board. Yes, sir. Into the board. Yes. So at this point, if you want field direction, it is tangent. Just imagination. This is circle. Tangent, imagine. The tangent is into the board only now. So here the magnetic field direction is into the board. Okay, into the plane of the board and perpendicular to it. See, like this. Imagine one hole in the board, into the board. Okay, children. So that's why the direction is given by this cross symbol. Okay. Now here, children. Here, how? Okay, see, like this, and it is coming like this only. Yes or no, children? Yes or no? Here into the means here it is what? Out of the board. So here it is out. Out means circle dot. So now you can give arrow marks like this. That's all. This is anti-clockwise. Anti-clockwise. Understand, children? And here the direction is into the board. I cannot draw into direction. Here the direction is this, tangent. Here the direction is this. Here the direction is this. So these are the directions of V bar. This is V bar direction. Okay, children. See, if current is parallel to the plane of the board, then at this point, the field is into the. At this point, the field is out of the, and here it is tangents. All are tangents. See, at this point it is outer. At this point it is in. And one more example I will give. If current is in opposite direction, see, if this is the current direction, okay, then just the field around this is circle, we know already. It is a circle. Then at this point, what is the field direction? See here, just place your right hand thumb in the direction of current. In the direction of current. Now, see, my four fingers is out of the board. My four fingers is out of the board. So, out means like this. I can show like this. Out. So now it forms clockwise. Clockwise. Okay, children. So, and here it is into the, see, like this it is. Yes or no? Now, if you want full one circle, you will fill like this only. At this point out of the, at this point into the. So here it is into the. Okay, and this is tangent. This tangent is actually into the board and perpendicular. V bar. Here it is outer, V bar. Here this is tangent. Here this is the tangent. Okay, children. So what you have to remember is these symbols. This symbol indicates that the direction of the magnetic field is into the board. Into the plane of the board and perpendicular, and this direction is the magnetic field is out of the board, means out of the plane of the board and perpendicular. Okay, so this is very important, children. In the next class also I will give some examples. Have a nice day.
ఏం లేదు సార్ మెనూకి వెళ్తాం కదా.
ఓ
Yes.
Good morning, children. Welcome to Biology Online class. So in the last class we discussed about lack of peron. So between the lack of peron is nothing but just examples to study about the gene expression in organisms. So what is the gene expression, children? In the last class itself we discussed that is nothing but flow of information from DNA to RNA, RNA to protein. In simple terms we can say that gene expression is nothing but synthesis of a protein from the DNA by the mRNA. That is nothing but gene expression. So which will be takes place in prokaryotic and eukaryotic organisms in the same manner only, but regulation is different. In yesterday class we discussed about regulation of gene expression. It will be only in one level in prokaryotes, that is transcriptional level. But whereas in eukaryotes there are 4 levels are there in the regulation of gene expression, that is nothing but switch on and switch off of the protein synthesis at 4 levels usually in the organisms. That is nothing but in yesterday class we discussed the first is transcriptional level, second one is processing level, that is modification, and third one is transport of mRNA from nucleus to the cytoplasm. Next, translational level. So regulation is nothing but already we know that switch on and switch off of a particular metabolic reactions. And for example, we discussed about the prokaryotes. In prokaryotes, beta-galactosidase enzyme is very essential to break down the lactose into galactose and as well as glucose. For lactose metabolism, this galactosidase enzyme is most important. So this enzyme production is totally dependent upon environmental condition. If in the medium lactose is there, then only beta-galactosidase enzyme will be synthesized by the gene expression. If the beta-galactosidase, if the lactose is absent in the medium, obviously there is no synthesis of beta-galactosidase improperly. So here you can easily observe the gene expression is totally controlled by metabolic, physiological and as well as environmental conditions. In yesterday class we discussed that the gene expression is generally controlled by the regulatory genes, and regulatory genes produces an accessory protein. That accessory protein binds to the operator region. In yesterday class we discussed about operator. Operator will be present beside the promoter region. So this operator region is a site of binding site for the accessory protein. These accessory proteins they regulate the expression of genes in generally. How they express, how they regulate the gene expression. That is the most important thing here. Some accessory proteins, when they bind to the operator region, in the time they may inhibit the translation process by, how can they do? They avoid the binding site or nothing but they inhibit the binding of RNA polymerase in the place of promoter region. So that's why there is no transcription. So obviously there is no transcription, there is no translation, there is no synthesis of protein. Sometimes these accessory protein, when they bind to the promoter region, then only there will be a switch on of the gene expression, that is nothing but transcription process will be going on. So by that we can easily understand the accessory proteins sometimes they may act as activators, sometimes they may act as inhibitors, which means they may activate the gene expression process, sometimes they may inhibit the gene expression process. This is the very important. So that's why these accessory proteins are also called as regulatory proteins. These are produced from regulatory genes. At the same time, this operator region is different for different type of operons. In yesterday class itself we discussed about operon. Operon means a structural gene, a polycystonic structural gene which is regulated by the common promoter and as well as operator. So many polycystonic genes are regulated by the common promoter and as well as operator. This type of system is called as operon. Generally operon structures are present in prokaryotes, but operons are absent in eukaryotes. Why? Because in eukaryotes the genes are split genes, which means the genes are coding sequences are interrupted by non-coding sequences. So that's why operons are present in prokaryotes. Operon is nothing but a polycystonic structural gene is having common promoter and as well as operator. So in yesterday class we discussed about lac operon. So we have taken example as a lac operon. Lac operon is nothing but that operon produce the protein, that protein is involved in the metabolism of the lactose. Here lact means lactose. Very, very important for competitive examinations and as well as previous examination. In yesterday class itself we discussed by taking the diagram of the lactoperon. So what happened in the during absence of inducer? What happened if during in the time of during the what happened in the presence of inducer in the lactose? All those things in yesterday class itself we discussed, children. So whereas in the lactose operon there are 3 genes are there, that is Z gene, Y gene and as well as A gene. Very, very important for competitive examinations. So if the transcription starts, obviously there is no any interruptions in the gene expression of the prokaryotes. So that's why transcription is a very, very important process. If the transcription is initiated, there is no stoppage of, there is no inhibition, there is no termination of the transcription and other things. Why? Because both the processes takes place simultaneously in bacteria. So that's why in this lactose operon or lactoperon, the Z, Y, A gene, 3 genes produces different type of proteins. That proteins are different type of enzymes and all the 3 enzymes are performing the same function. That is nothing but 3 are involved in what is it? We can say simply they are involved in lactose metabolism. So Z gene function is production of beta galactose enzyme, Y gene enzyme is production of permease enzyme, A gene function is production of transacetylase enzyme. The function of permease is it will increase the permeability of cell to the lactose. That is nothing but it will allows the entry of lactose molecules inside the bacterial cell from outer surroundings. That is the main function of permease enzyme. And next, transacetylase enzyme. Generally, it will activate the beta galactose enzyme. And the final one, beta galactose enzyme function is which will hydrolyze the lactose into galactose and as well as glucose. So how it will be takes place? In generally from the lactoperon, lactose is the main important component. If lactose is present in the medium, then only there will be a synthesis of beta galactose enzyme. So here lactose is called as inducer. Very, very important. Here inducer means which will inhibit the binding of repressor protein to the operon region. So during the lactoperon, children, whatever we discussed in the yesterday class, in the lactoperon, the repressor protein continuously synthesized. Synthesis of repressor protein is most common if the lactose is present in medium or absent in the medium. The repressor protein will be continuously synthesized. Why? Because the repressor protein is synthesized from the regulatory genes. Always it will be synthesized. If the lactose is present in the medium, that lactose will bind to the repressor protein. So by that, the repressor protein will be inhibited. Prevent this lactose will prevent the binding of repressor protein at the operator region. So by that, now promoter region is free to accept the RNA polymerase enzyme. So RNA polymerase will bind to the promoter region. So by that, there will be a transcription takes place in the Z gene, Y gene and as well as. So that's why lactose is called as inducer. Very, very important. Here in lactoperon, lactose is inducer which will bind to the repressor protein and repressor protein inhibit repressor protein cannot bind to the operator region. So that's why promoter region is free and it will accept the particular RNA polymerase enzyme binds to the promoter region and it will initiate the process called transcription. That is nothing but synthesis of conditions are very, very important. So if the lactose is present in the medium, that is nothing but inducer. Here lactose is the medium. If the lactose is present in the medium, it is called as inducer. And the next condition for the initiation of lactoperon. This is also very, very important, children. In our textbook they are given, but many of we never discussed about these things. Why? Because these are not important. Many of them are they may think that it is not important, but in my view everything is important for the competitive examinations and as well as PUs. So that's why It's a very important concept. Conditions for regulation of lac which conditions? If the conditions are, if favorable conditions are there, then only the lac operon will be activated and there will be a transcription. So what are the conditions? First of all, there should be a lactose. Lactose should be present in medium. And the second one, lactose should be present in the medium. That is the first and the most important thing. And next, absence of glucose. This is somewhat we will get some doubts. Why glucose should be absent in the medium? If glucose is present in the medium, what happened to the lac operon? Again, we are going to discuss what is the main reason. And the third one is permease. Permease allows the entry of lactose inside the cell. Inside the cell. So first of all, lactose should be present in the medium, okay. And then another one is there should be an absence of glucose. Why glucose should be absent here? During lac operon, children, what happened? After the lac operon, the beta galactosidase enzyme, this is lactose, it will be break down in the presence of beta galactosidase enzyme. What is the name of enzyme? Beta galactosidase enzyme. So by that lactose will be converted into glucose and galactose. Children, we already know about the activity of the enzymes. We already know about the competitions in enzyme activity, that is generally in enzyme inhibition, generally competitive enzyme inhibition, feedback enzyme inhibition, and as well as non-competitive inhibition. So there will be inhibition of enzymatic activity in different forms. Again, we are going to discuss. So already we know about the biomolecules, right? So what happened here, children, during hydrolysis of lactose, in the presence of beta galactosidase enzyme, lactose will be converted into glucose and as well as galactose. If more amount of lactose is there in the medium, the glucose will be continuously released or produced. What happened? This product, whatever it is produced during hydrolysis of the lactose, this glucose will inhibit the enzymatic activity of the galactose that may lead to feedback inhibition. That may lead to feedback inhibition. What is meant by feedback inhibition? Feedback inhibition is nothing but inhibition of enzymatic activity by the product. Whatever the product which is produced after the enzymatic activity, the product again binds to the beta galactosidase enzyme and which will inhibit the process of hydrolysis of lactose. Even though lactose is present, there is no hydrolysis, there is no production of energy. So that's why to prevent the feedback inhibition, glucose should not be there in that particular medium. So that's why that is the main important thing here. And next, permease allows the entry of the lactose inside the cell. One thing we will get, one doubt we will get from this one. Without the transcription process, without the switch on of, what is the switch on of the lac operon, how the permease is synthesized before in the cell, inside the cell. So permease is synthesized from one of the gene called Y in the lac operon. If there is no regulation, how the Y gene can synthesize permease and how that permease will function that increase the permeability of cell to the lactose. Here one thing we should remember, actually the lac operon will be continuously functioning. Children, they will produce here, the lac operon will function, it will switch on continuously, switch on some very less amount of permease will be synthesized. Obviously, lac-operon functions continuously, children. Already I said that repressor protein continuously synthesized. The repressor protein will bind to the operator region. Then only there will be a surface of what is that synthesis of the 3 enzymes. But very less amount of permease enzyme will be synthesized during the lac-operon. If even though in the absence of lactose also, in the absence of lactose, there will be a synthesis of some amount of permease. Whatever the permease which is present, very low concentration, that permease what it will do, it will allow the lactose inside the cell. So now inside the cell lactose is present. So by that, there will be, if inducer is present, obviously that inducer will bind to the repressor protein, and now operator region is promoter region is ready. So article will bind to the promoter region, then it will start its process, that is nothing but synthesis of beta galactosidase, permease, and as well as trans-acetylase enzyme. So here by this we can easily understand what type of regulation it is, either negative regulation or positive regulation. This is the most important point we should discuss, children. Here continuously repressor protein is synthesizing, and the function of this repressor protein is always binds to the promote operator region. The main intention of accessory proteins is to switch off the gene expression. So that's why we can easily say that the lac-operon is negative regulation. It is the best example for negative regulation. Why it is example for negative regulation? Because the function of accessory proteins always they switch off. They want to switch off the lac-operon. They want to switch off the gene expression in the lac-operon. So by that there is no synthesis of beta galactosidase. So this is the negative regulation of lac-operon. Sometimes if you go to the higher explanation and as well as description, this lac-operon is also one of the positive regulation. But initially we can easily understand that lac-operon is nothing but it is a negative regulation of gene expression. Why? Because accessory proteins continuously synthesized. The main function of accessory proteins are switch off the gene expression. So that's why it is the best example for negative regulation. So not only lac-operon, children, in bacterial cells many types of operons are there. Say for example, tryptophan-operon, as well as not only that alanine-operon, as well as arabidose-operon, histidine-operon, valine-operon. So like that different type of operons are there in bacterial cell. So each operon function is there having a group of structural genes, and the group of structural genes produces different type of proteins, and all the proteins are doing the same function. That is the main importance of this operon concept. So this is about the operon, children. I think you understand what are the conditions which are required for the lac-operon regulation. That is nothing but presence of lactose, absence of glucose. So what happened when the absence of glucose is there? Permease enzyme allows the entry of the lactose inside the bacterial cell. So by that lactose binds to the repressor protein. When the promoter region is ready to bind with the RNA polymerase enzyme, RNA polymerase binds with the promoter region. Now it will start the transcription process. So by that there will be a synthesis of proteins called beta galactosidase, permease, transcriptase. So during examination, no need to explain all those things, but should write what is the importance of operon, what is meant by operon, what is lac-operon, what are the components are there in lac-operon. One is IG. IG function is producing regulatory proteins. The regulatory protein is called as repressor protein. And next, promoter. What is the promoter? What is the use of promoter? Next, operator. What is promoter? What is operator? What is the use of operator? And next, genes. ZYA. What is Z gene? What is its function? What is Y gene? What is function? A gene function. So what are the functions of each enzyme? That is beta galactosidase, permease, and trans-acetylase. And next, by the diagram, whatever the diagram which we discussed in yesterday's class, in the absence of inducer, what happened? So very simple diagram. The repressor protein binds to the operator, then there will be a termination of transcription. There is no synthesis of any protein. In the presence of inducer, what happened? Repressor protein is linked with it will be inhibited by the binding of the inducer. So by the RNA polymerase binds to the promoter, and then there will be synthesis What happens in the absence of inducer? What happens in the presence of inducer? That is a very, very important you should write in the lab paper. And this concept is very, very, very important for competitive and as well as PUC examination. So this is about the lab paper, children. And next we are going to discuss about human genome project. Human genome project. Before we are going to discuss about what is this human genome project, what is the importance of human genome project, first of all we should know what is genome. What is meant by a genome? Genome is nothing but a haploid content of DNA present inside an organism. Is nothing but a cell of an organism is nothing but genome is a haploid content of DNA inside the cell. Simply we can say, already we know about many times we discussed about haploid and diploid. If only one set of chromosomes are present, that is the condition is nothing but haploid condition. If the two sets of chromosomes are present, that condition is nothing but diploid condition. So human beings are diploid because they are having 23 pairs of chromosomes. If you want to know the sequence of the chromosomes, no need to go for more experimentation, no need to no need to know about all the 46 chromosomes. If you know the information of 24 chromosomes, we can easily understand the information of another 22 chromosomes. Right, children? No need. So that's why here in human genome project, what they are doing, children, to know about the genome sequence of human genome by different type of experimentations, all those things we are going to discuss. What is meant by genome, children? A haploid content of DNA present inside the cell. So haploid content is nothing but we are going to study only a single set of chromosomes. Only one set of chromosomes. Why? What is the importance of the study of the human genome project? Before we are going to discuss about what is this human genome project and all. First of all, we should know what is the importance. Already we know that human genome is nothing but project is nothing but study about the sequence present in the human genome. So what about the sequence is nothing but nucleotide bases. So how they are arranged? If you take chromosome 1, so it is also composed of DNA. If you stretch the DNA into the nothing but into a thread. Again, what is the arrangement of adenine, thymine, guanine and cytosine? That is nothing but sequencing. How they are arranged? That is nothing but the sequencing of this genome. So what is the importance to know? What is the importance? What is the first step laid in the human genome project is nothing but, if you see, children, even though we are human beings, but we are having a lot of differentiation when compared to the two individuals among ourselves. Say for example, if you take two individuals from the same family, again their appearance, sometimes their pigmentation, sometimes they are eye color, they may be hair, and as well as they may be nails, whatever it may be, there will be something differentiation is there. The two individuals are not the same, even though they are belongs to the same species. Here in human beings also, even though we are belong to the same species, but there is a lot of differentiation. Some differentiation is there in between the two individuals, and these differences are mainly came from due to the genetic makeup. If you know the genetic makeup is nothing but the genome itself only, that is DNA. If you know the nucleotide sequence of the DNA, the nucleotide sequence of DNA is a very, very important component to change the genetic information, and also it will change the characteristic features of a particular individual. So due to the differentiations among the DNA, genetic makeup of the DNA, only it is possible why the two individuals of same species are different. Some people, they may are having blue color eyes. Some people, they may are having total white color hairs. Some are, due to the lot of pigmentation, they may appear as more dark color. The genetics only itself will discuss a lot of things about the inheritance and as well as variation. Why? when those same species there's a lot of differentiation because of their genetic makeup. Genetic makeup is nothing but the sequence of nucleotide present in the DNA. So, in the time scientists have that particular interest to know about the sequence present in the human genome. So, that's why they laid a stepping stone to study about the sequence present in the human genome. Human genome is nothing but taking all the 23 chromosomes, it's nothing but single set of chromosome to study their sequencing, and so by that you can easily understand there is a lot of applications are there from this human genome project, children. If you know the human sequence, whatever it may be the genetic disorder, so when you know the sequence, that sequence will give some idea about the genetic disorder. If any genetic disorder is came into a particular human, obviously we know already the genetic sequence, so that's why we can correct it by gene therapy. Again, we are going to discuss about these things in biotechnology. So very useful, children. These are all human genome project. So generally these human genome project is started in 1990. It is started in 1990. Children, in the time scientists start to complete this human genome project in 2010. Actually, it has to be completed in 2003, but officially it is completed in 2006. Officially it is completed in 2006. In 2006, the last chromosome is a sequence that is nothing but chromosome 1 is sequenced in 2006. Again, we are going to discuss about all this. Sequencing is nothing but knowing the nucleotide base bases present in the DNA. That is nothing but sequencing only, children. So here, the project started in 1990 and it has to be completed in 2003. Actually, majority of the work is completed in 2003, but only one chromosome left behind. That chromosome 1 is sequenced in 2006. The sequencing of chromosome 1 is completed in 2006, children. So that's why I can easily say that 16 years it has taken to complete the human genome project, but officially they said that the human genome 13 years nearly taken to complete the human genome project. Now we are going to discuss about some importance of this human genome project and some special features of human genome project. This human genome project is also called as mega project. Why it is called as mega project? Very important, children, for theory examinations especially. So human genome project is also called as mega. Mega means huge. It is a big project. Why it is called as big project? There are several reasons why human genome project is called as mega project. So already we know human genome project is nothing but to know the nucleotide base sequence present in the human genome. Genome is nothing but haploid content of DNA. Taking all the chromosomes, single set of chromosome, and we will study the nucleotide sequence. That is nothing but ATGC only. That is nothing but adenine, thymine, guanine, cytosine. But their arrangement will be different. Adenine, guanine, cytosine may be adenine, thymine, guanine, cytosine, adenine, cytosine, guanine, thymine. So guanine, adenine, thymine, cytosine. So like that, the arrangement of nucleotide base sequence may be different. So we are going to know the sequence of human genome by this project. So first of all, scientists say it is a mega project or huge project. The reasons are very important, children. Why human genome project is called as mega project? The first thing is human genome length. What is the length of human genome, children? 3 into 3 or 3 into 10 to the power of 9 base pairs. 3 into 10 to the power of 9 base pairs. Actually, it is 3.3 into 10 to the power of 9 human genome. So, the length, if you take, obviously, it is nearly some 3 billion. 3 billion is nothing but 300 crores of nucleotide bases. So, it is a huge length. At the same time, they calculated the amount to sequence all the nucleotide bases present in the human genome. Say for example, in that time, during 1990, biologists or scientists estimated the cost for the sequencing of human genome. So nearly $3 are required to sequence one base pairs. So there are $3 are required to sequence one base pair. So imagine if the $3 are required to sequence the one base pair present in the human genome, then calculate how much cost is required to sequence the 3 billion base pairs. So there are nearly $9 billion the estimated cost in the 1990 children. So $3 required to sequence one nucleotide base in the genome. So if you calculate like that, for the length of human genome, that is 3 into 10 to the power of 9, that is nothing but 3 billion. So 1 billion, one base pair cost is $3. So 3 billion base pair cost is $9 billion. It is very huge amount. So if you take the cost effective, it is the mega. Based on the cost effective also we can say it is a mega project. Based on the length also, it is called as a mega project only. The next one is storage of information. If the information is, this is very important children. If the information is stored in a type form, if the information is stored in a type form, so how many books are required here? Say for example, the each page contains 1000 letters and each page contains 1000 letters. Such a type of pages should be there. Nearly 1000 pages is there in each book. So we can say that such a type of pages will be there. How many pages will be there in a book? Each book contains 1000 pages. And how many books required? This type of 1000 pages containing books. At the same time, each page containing 1000 letters. So such a type of books nearly there are 3300 books are required to store the information which is isolated from the human genome. How many books are required here, children? Nearly 3300 such books are required to store the information of human genome. That is nothing but to store the nucleotide sequence. What is the nucleotide sequence, children? That is nothing but ATGC only. That ATGC may be, the arrangement may be different. So here, such a type of ATGC information should be stored. So how many books are required here? 3300. Again, each book contains how many pages? 1000 pages. And each page contains how many letters, children? 1000 letters. So that's why here we can say, based on the storage of information also, it is very big project or huge project. So that's why there is a need of new branches to store the databases of this human genome. Database is nothing but, an information only. So that's why scientists developed a new computational devices to store the information of human genome. So that branch which deals with the devices and as well as techniques to store the biological data is bioinformatics. So to store all these information, Human Genome Project is related with the bioinformatics. Very, very important, children. This is bioinformatics. Bioinformatics is nothing but it is an interdisciplinary subject or interdisciplinary branch. Sorry, it is not a subject. It is an interdisciplinary branch which is having the computational. It is nothing but a computational or computer device. It deals with the computer device, and the computer devices are having tools and as well as techniques. In simple form, we can say nowadays they are having a different type of softwares to store the biological data. What is this data? Data is nothing but information only. Say for example, children, 3,300 books are there to store the information of human genome. Again, if you store this information in 3,300 books, again if you want to analyze, if you want to go for reference, is it possible to study, is it possible to understand the information from the human genome by the reading the books? It is impossible, children. So that's why scientists develop a software and as well as tools to store such a huge information in computer devices by the branch called bioinformatics. This branch helps to store the information not only which stores the biological data. Biological data is nothing but the nucleotide sequences of different type of organisms. They stored in the form of biological data only. That biological data helps for reference, retrieval, and as well as storage and as well as analyze. Whenever you want to analyze, what is the difference between two individuals? Again, you can easily analyze by taking this the biological data with other person. How is it possible, children? When it is there, when it is stored in a particular manner. So that's why here these computer devices helps to analyze and as well as retrieve, reference, refer the particular biological data whenever we want. That branch is developed by many of the biologists, physicists, and as well as chemists. During modern days, the branch is nothing but bioinformatics. Bioinformatics is not there. Human genome project, completion of human genome project is very, very difficult, children. Why? Because to store such information, it is very difficult, and to understand the particular information, it is impossible. So that's why biologists develop this bioinformatics. So human genome project is completely, it is related with the bioinformatics. What is bioinformatics, children? Very, very important. It is an interdisciplinary field that develops methods and software tools for understanding biological data. Not only storing, to understand the biological data, that is nothing but bioinformatics. It is having information of living organisms. That's why it is called as bioinformatics. So this is about the reasons why the Human Genome Project is called as mega project. First one, it is the genome length is more. The second one, it's more cost effective. And third one, it is very, what is it? Dense data to store in a book. So that's why the Human Genome Project is called as mega project. And next, goals of HGP. Goals of HGP. Simply we will call it as HGP. HGP is nothing but Human Genome Project. Children, don't confuse with goals and as well as salient features. Again, we are going to discuss in the next class more salient features and as well as methodologies of Human Genome Project. And today also, I think the time is finished. So that's why we are going to stop here only. So tomorrow class we are going to discuss about goals of Human Genome Project, children. So what are the main intention of Human Genome Project? Why they led to study about the human genome? If there are any goals, all those things we are going to discuss in the next class. And not only that, tomorrow class we are going to discuss about which organizations are having the partnership with this Human Genome Project. That is US healthcare centers and as well as Wellcome Trust. Many are there. Tomorrow class we are going to discuss about all those things. Up to this, what is this Human Genome Project? This class we that? And why Human Genome Project is called as mega project? This is a very, very important question for 3 marks. So this is about Human Genome Project, children. In tomorrow class we are going to discuss about the further things. Thank you so much.
Good morning, children. In the last class, we completed exercise 1.2 and example problems are also over. Okay. Now start with problem number example 12. All of you put textbook in front of you. Page number 9. Page number 9. Last class example 10 was over. Example 11 we already did in the exercise 1.2. In the exercise 1.2 third problem is the same as example 11. So I am going to example 12. Right? Example 12. Example 12. Page number 9. Show that f from n to n given by f of x is equal to set of x plus 1 comma if x is odd, x minus 1 comma if x is even, is both 1 1 and onto, is both 1 1 and onto. Right, solution. Understand the question. Show that f from n to n given by f of x is equal to, here f of x is defined like this. We are going to show that f is both 1 1 function and onto function. F of x is given. What is f of x? X plus 1 if x is odd number. If x is odd means 1, 3, 5, 7 and so on. F of x is x plus 1. If x is even number, what is image is x minus 1. We are going to prove it is both 1 1 and onto function. Okay? Write the given function. Given that f of x is equal to set of x plus 1 comma if x is even, if x is odd, x minus 1 comma if x is even. First of all, I am going to check whether it is 1 1 or not. 1 1 function means different elements have different images. Take two different elements. So natural here set is what? Natural number. So take any two elements, 1 comma 2. So let 1 comma 2 belongs to n. I am going to find their images. Then f of 1 is equal to, see that f of 1 is odd number. So formula is x plus 1. 1 is odd. So x plus 1. 1 plus 1 is equal to 2. F of 2 is equal to 2 is even number. So function is x minus 1. 2 minus 1 is equal to 1. See that 1 and 2 have different images. So it is 1 1 function. So similarly, f of 3 I am finding. F of 3 is equal to 3 is odd number. So odd number formula x plus 1. So 3 plus 1 is equal to 4. F of 4 is equal to 4 is even number. So f of x is x minus 1. 4 minus 1 is equal to 3 and so on. See that different elements have different images. So it is one function. Since different elements have different images, therefore f is 1 1. Right. Now I am going to check whether f is onto or not. Onto function. Onto function means so many ways are there. Range equal to codomain. Range. What is range? Range means set of images. What are images? 2, 1, 4, 3, 5, 6 like that. So range of f. Range of f is equal to set of images. Images are written in order 1, 2, 3, 4 and so on. Images are 1, 2, 3, 4 and so on. This is nothing but our natural numbers only. That is nothing but our codomain. Second set is n only. Range of f is 1, 2, 3, 4 and so on. That is nothing but natural number system. That is nothing but codomain. So range equal to codomain, we can say that f is onto function. Therefore, f is onto. See that f is both 1, 1 and onto. Therefore, f is both 1, 1 and onto. F is both 1, 1 and onto. Okay, that is the answer. Okay, that completes exercise 1.2 before examples also. Example 11 is same as 1.2 exercise, second question, third problem. Already we did. Right. Write it. Right. Side heading composite function. Side heading composite function. Okay. Define composite function. What is the definition of composite function is? Let us assume that f is a function from a to b. First listen the definition. After that I will give you the notes. First listen. Let us assume that f is a function from a to b and g is a function from b to c. F is going from a to b. G is going from b to c. Then g circle f goes from a to c. G circle f goes from a to c. Here g circle f is called. Here G circle f is called composite function of f and g. Combine two functions combination. So composite function of f and g. Here G circle f is called composite function. F is function, G is function. G circle f is called what? Composite function. Combination of two functions. Diagrammatically it can be represented as. See, let us consider three sets. A, B, C. Okay? F is going from A to B. G is going from B to C. F is going from A to B. G is going from B to C. G circle F goes from A to C. This is going from A to C. Suppose take one element in the first set, A belongs to A. Its image present in B under F, A image under F is F of A. So F of A belongs to B. F of A image under G function is G of F of A. See, I take an A element, its image is F of A. Its image is under F, G of F of A. Okay, like this diagram. This is the composition function diagram. Okay, if F from A to B, G from B to C are two functions, then G circle F from A to C is again a function. That function is called composite function. And note is number one, G circle F of X can be written as G circle F of X can be written as G of F of X. G circle F of X can be written as G of F of X. Right. Second, F circle G of X can be written as F of G of X. Here, circle, this is called composition. Circle is called composition of two functions. Circle symbol, composition symbol is circle. G circle F of X can be written as G of F of X. F circle G of X can be written as F of G of X. Circle changes to brackets like this. This is composition of two functions. Composition of three functions may be like this. H circle G circle F. Composition of three functions. H circle G circle F or H circle G circle F. Both are called composite functions of three functions. F goes from A to B, G goes from B to C, H goes from C to D. Like that is there. H circle G circle F, H circle G circle F are called composite functions of three functions. Now another definition. Invertible function. Invertible function. Invertible function. You know invertible matrix. In matrices determinant chapter, invertible matrix. What is invertible matrix? Let capital A be a square matrix. Let capital A be a square matrix. Then there exists another square matrix B. Suppose one matrix, square matrix is there, compulsory there exists another square matrix B such that AB is equal to BA is equal to I. A is given matrix. I am going to find B another matrix such that their product is identity matrix. Then AB is equal to BA is equal to I. Then B is called inverse of A. And A is called inverse of B, and it can be written as B is equal to A inverse. B is called inverse of A. That is invertible matrix definition. If A is a square matrix, then there exists another square matrix B such that their product is equal to identity matrix. AB is equal to BA is equal to I. If the product is identity, then one is called inverse of other. So we can write at B is equal to A inverse. Okay, that is matrices. We are under functions chapter. So invertible function. Same invertible function means let us assume that F is a function from A to B. Let us assume that F is a function from A to B. There exists another function G from B to A such that G circle F is equal to IA. I means identity function on A, and F circle G is equal to IB. F is one function, given function. You are going to find another function. F is given function. You are going to find another function in such a way that their composition is identity function. F circle G equal to IB. If two conditions are satisfied, then that function is said to be invertible function of the given function. So then G is called inverse of F. It can be written as G is equal to F inverse. Here G is called inverse of F is called inverse of G. So vice versa. If F is a function from A to B, then there exists another function G from B to A such that G circle F equal to IA. I means identity function defined on A. F circle G equal to IB. Two conditions are satisfied. Then G is called inverse of F. F is called inverse of G, and it can be written as B is equal to A inverse in the same way G is equal to F inverse. Right. And note is F is said to be invertible. When we will say one function is invertible, invertible means inverse exists. F is said to be invertible. F is said to be invertible. When inverse will exist is if and only if F is bijective function. If F is bijective, then only inverse is possible. F is both 1, 1 and 1, 2. Both 1, 1 and 1, 2. If any function said to have inverse, when F inverse exists is if and only if it satisfies bijective function. It is both 1, 1 and 2, then only go to F inverse. In the case of inverse trigonometric functions chapter, see, sin x domain range. What is sin x domain is capital R, real numbers. Range is sin values are always lies between -1 to 1. But we discussed sin x domain is real number system. In the place of x, you can put any real number. Answer is defined. Range is my closed interval -1, 1. What is sin x? Sin 0, 0. Sin 180 also 0, and so on. See that 0 and pi have same image. 0 and pi have same image. So it is not 1, 1 function. So sin inverse not exist too. But we did the chapter also, sin inverse x chapter. Sin inverse x, cos inverse x, tan inverse, cot inverse, secant inverse, cosecant inverse. To make sin x function bijective, we are restricting the domain. That domain makes as closed interval -π/2 to +π/2. Range is same, -1, 1. Take any value between -π/2 to +π/2. No value can be repeated here. Then automatically sin x becomes bijective. Then you are able to find sin inverse x function, cos inverse x function like that. Inverse trigonometry chapter, actually sin x, cos x, tan x, cot, secant, cosecant, all are not bijective functions. To make them bijective functions, we are restricting the domain. Okay, right. That is about composite function. What is composite function? G circle F, F circle G are called composite functions. Invertible function means what? Two conditions has to satisfy. These two formulas. G circle F is equal to IA and F circle G equal to IA. When both conditions are satisfied, then that function is said to be invertible function. Notice when F inverse exists is if and only if F is both 1, 1 and 2. Then only F inverse is exist or possible. In the case of matrices, see, A inverse exists. A inverse exists when if and only if that A not equal to 0. A inverse formula adjoint A by det A. Det A value not 0, then A inverse exists. A inverse does not exist when det A equal to 0. Like that. Okay. Write the notes. Okay, put the heading composite function. Composite function. If F colon A to B, comma G colon B to C are two functions then G circle F is also a function. Full stop. It is called composite function of. It is called composite function of F and G. It is called composite function of F and G. Okay, draw the diagram. Draw the diagram and write a note also. Right. Okay. Invertible function. Side heading. Invertible function. Write down the definition. A function F colon A to B. F colon A to B is said to be invertible. Is said to be invertible if there exists another function. If there exists another function G colon B to A, G colon B to A. F goes from A to B, G goes from B to A to B, B to A, B to A, such that G circle F is equal to IA. G circle F is equal to IA and F circle G is equal to IB. Here G is called inverse of F. Inverse of F and is denoted by G is equal to F inverse. If two conditions are satisfied, you can write G is equal to F inverse. F inverse. Write note also. Note. F is said to be invertible. Double implies invertible means inverse exists. F is both 1 1 and onto. Both 1 1 and onto. Okay. Exercise 1.3 is removed from the syllabus due to corona. They removed 1.3 exercise. So let us go to exercise 1.4. Okay, before going to start the exercise 1.4, first let us know some introduction. Side heading binary operation. Side heading binary operation. Binary operation. Okay. March 2019 as a 1 mark question. First question, define binary operation. Give an example. Okay. March 2018, what they asked to define bijective function. March 2018, define bijective function. 2019, define binary operation. Listen. 1.3 exercise is removed from the syllabus. 1.4 exercise, introduction I am giving. First listen, after that I will give you the notes. Binary operation. Define binary operation. Let S be a non-empty set. Let S be a non-empty set. S having some elements, it is not empty. S having some elements. Take two elements. A belongs to S, comma B belongs to S. S is one non-empty set. I taken two elements, A belongs to S, B belongs to S. And A star B, A star B is also belongs to S. Then star is said to be binary operation. What is binary operation? Take two elements in the set. Take two elements in the set. Apply the operation. Operation is star. Star may be plus, minus, into, divided by LCM, HCM, or anything. What they said that general operation star. This symbol is star. Right? Plus like this, middle like this, star. Now, apply the operation, either addition plus what they said that operation. If the result belongs to same set, then that operation is said to be binary operation. If not, it is not a binary operation. Example: take the set of natural numbers. Take the set of natural numbers. Take two natural numbers. 2, 3 belongs to n. Apply addition. 2 plus 3 is equal to, what is 2 plus 3? 5. 5 is also natural number. I have taken two natural numbers, so I applied the operation plus. Result is also natural number. So we can say that plus is a binary operation. Plus is a binary operation on n. I am going to check whether minus is binary or not. Take two natural numbers. 2, 5 belongs to anything. 2, 7 belongs to n. Apply minus. 2 minus 7. How much 2 minus 7? Minus 5. Does not belong to n. So we can say that minus is not a binary operation. Take two elements, apply the what operation they said. If the result belongs, we can say binary, otherwise not binary. Plus is a binary operation on n. Minus is not a binary operation on n. Similarly, multiplication 2 into 7 is equal to 40 is also belongs to n. So multiplication is a binary operation. What about division? 2 divided by 7 is equal to 2 by 7 does not belong to n. So division is not a binary operation under natural numbers. Okay, that is binary operation. Let us discuss types of binary operations. Types of binary operations. Okay, number 1, commutative operation. Commutative operation. Define commutative operation. You know commutative law in 6th class itself. Commutative law, associative law, closure law, like that. Now, commutative operation. Define commutative operation means let S be a non-empty set. Let S be a non-empty set. And star is a binary operation. Star is binary operation. If A star B is equal to B star A, then star is said to be commutative operation. Same as commutative law. What is commutative law? A plus B is equal to B plus A is called commutative law under addition. It is A star B equal to B star A is called commutative operation on the set S, where A comma B belongs to S only. Compulsory taken elements. What you take, you have to take from set only, given set only, where A comma B belongs to S. Now, associative operation. Associative operation. Right. Associative operation means just like associative law. Let S be a non-empty set and star is a binary operation. If A star B star C, A star B star C is equal to A star B star C. If LHS is equal to RHS, then star is said to be associative operation. Same as associative law. You know, see what is associative law? A plus B plus C is equal to A plus B plus C. Brackets can be interchangeable. That is said to be associative operation. Condition is where A comma B comma C all belongs to given set only. Commutative is A star B equal to B star A. Associative means what? A star B star C is equal to A star B star C. Okay. 3. Identity law. Identity element. Identity element. Identity element. Right, see, identity element means let S be a non-empty set. Star is a binary operation. First of all, to check commutative, associative, identity, anything, star must be biject. Star must be binary. If the star is binary, then only you go to commutative, associative, anything. If star is not binary, even though if they ask commutative, wrong only. So first check star is binary or not, then only go to further operations. Let S be a non-empty set. Star is a binary operation on S. If A star E is equal to E star A is equal to A, where A comma E belongs to S, is called identity law or identity element. What is identity law? A star E is equal to E star A is equal to A. Means A star E equal to A only. E star E also A only. Both are equal to A. Then E is called identity element in the set S. E is called identity element. For example, see. What is identity law? A star E is equal to A. Identity law. A star E is equal to A. 2 plus is equal to 2. See, here operation is plus taken. By what adding same element 2 comes? By what adding same element 2 comes? 0. So 0 is called additive identity element. 0 is called additive identity element under addition. See, suppose I have taken 100 multiplication. Same, A star E is equal to 100. 100 if we multiply with what? Same 100 will come 1. So 1 is called multiplicative identity. Under multiplication, 1 is identity element. Under addition, 0 is identity. Under multiplication, 1 is identity. So E is called identity elements. Identity elements. Formula is A star E is equal to E star A is equal to A. Right. 4. Inverse element. Inverse element. Inverse element means let S be a non-empty set. S is a non-empty set. Star is a binary operation. If A star B is equal to B star A is equal to E, A star B is equal to B star A is equal to E, then B is called inverse of A and A is called inverse of B. Just like matrices we said now, AB is equal to BA is equal to I, then AB, A star B is equal to B star A is equal to E. Then B is called inverse of A and A is called inverse of B. Can be written as B is equal to A inverse. Similarly, B is equal to A inverse. B is called inverse of A, where A A, B, E all belongs to given set only. Okay. Suppose example take. Example, see, A star B is equal to E. This is inverse law. 2 into, I first take plus. I take one element 2. Under addition, what is identity element? Under addition, identity element is 0. So 0. By what adding you will get 0? By what adding you will get 0? Minus 2. So minus 2 is called inverse of 2. Minus 2 is called inverse of 2. Right, take 100. I take 100. By identity element, multiplication, identity element is 1. So 1. By multiplying what you will get 1 only? 1 by 100. So 1 by 100 is called multiplicative inverse of 100. Minus 2 is called additive inverse of 2. 1 by 100 multiplicative inverse of 100. So like that. So simply understand what is binary operation. Take 2 elements, apply the operation. Result belongs to given set. Star is said to be binary. Plus is a binary operation on n, but minus is not binary on n. Commutative operation formula A star B is equal to B star A. Associative operation formula A star B star C is equal to A star B star C. Identity element formula A star E is equal to E star A is equal to A. What is inverse element formula? A star B is equal to B star A is equal to E. Okay, that is the introduction about the exercise 1.4. Now write the notes. Yesterday, two members got above 40 marks. So out of 45, 42 members got. So Naushik Moria, he got 39, very good. And Zuveria, she got 41 out of 45 marks, very nice. Some waste fellows are there. I cannot do anything. You cannot get either NEET seat, you cannot get JEE seat, CET seat. Always you are thinking that we can become doctor. So same only, if you do hard work, you can manage, otherwise waste only. That seat also not come, this seat also not comes. Simply you can stay hollow. Choice is yours, future is yours. We are only umpires, we will decide, we cannot decide your life. You have to decide your life. We are doing our duty, our level best, choice is yours. Right. Binary operation. Let S be a non-empty set. Let S be a non-empty set. If A belongs to S, comma B belongs to S, and A star B belongs to S, then star is said to be binary operation on S. Right. Or another definition I am giving. Right. A binary operation star defined on the set is a function from star colon A cross A to A, star colon A cross A to A, binary operation, it is also a function. That's why in functions chapter we are discussing. It is also function. Going from A cross A, Cartesian product of A to A cross A to A. So like that. Example. In the set of natural numbers, n plus is a binary operation, because the addition of two natural numbers is again a natural number, right? That is 2, 3 belongs to n, implies 2 plus 3 is equal to 5 belongs to n. Okay, but minus is not a binary operation. On n because the difference may or may not be a natural number. That is example. 2, 3 belongs to n implies 2 minus 3 is equal to minus 1 does not belongs to n. Suppose if you take 3 minus 2 is 1, but any one subject fail, result is fail only. If one subject fail, result is fail only. I will write fail subject only. So many passing subjects are there, but fail is overall result fail. Right. Types of binary operations. Types of binary operations. Number 1, commutative operation. Right. A binary operation start defined on the non-empty set S is said to be commutative if A star B is equal to B star A, where A comma B belongs to S. Okay. Second, associative operation. Associative operation. A binary operation binary operation. Star defined on the non-empty set S, non-empty set S is said to be associative if A star B star C is equal to A star B star C, where A comma B comma C belongs to S. A, B, C belongs to S. Okay. Now 3. Identity element. Identity element. Let star be a binary operation on non-empty set S if A star E is equal to E star A is equal to E is equal to A, where A comma E belongs to S, then E is called identity element. Right. Example.
Up to 1220. 12.
Note. Example is note you can write. Note. Number 1. Additive identity element. Additive identity element. Is equal to 0. 2 plus 0 is equal to 2. Second, multiplicative identity element. Is equal to 1. Side 100 into 1 is equal to 100. Right. Fourth definition. Inverse element. Let star be a binary operation on S if A star B is equal to B star A is equal to E, where A comma B comma E belongs to S, then B is called inverse of A. And is denoted by B is equal to A inverse. Right. Note. Number 1. Additive inverse of 2 is minus 2. Second, multiplicative inverse of 2. Multiplicative inverse of 2 is 1 by 2. 1 by 2. Right. So 2 plus minus 2 is equal to 0 and 2 into 1 by 2 is equal to 1. A star E. A star B is equal to E. A star B equal to E like that. Minus 2 is called additive inverse of 2. 1 by 2 is called multiplicative inverse of 2. Okay, that is introduction about 1.4 exercise. Afternoon 2 o'clock we are having maths period. I will start the exercise 1.4. Okay, thank you.
Next level.
Physics or
Physics.
physics.